And now for the chain rule, section 14.4. We're going to start with an example from Math 3a. Find the derivative of this function. So when you have one function, like x squared, substituted into another function, that's when we need to use the chain rule. And so the derivative would be, take the derivative of sine, which is cosine, and you can only take one derivative at a time, so the x squared has to stay there. Then the chain rule says multiply with the derivative of the inside function. That would be a 2x. Hopefully that was a review. Now, what about if it was a little more complicated? How about sine of e to the x squared? So now we have three functions. The sine function and this e function was substituted into it, and then the x squared function was substituted into that. So the derivative will be, derivative of sine is cosine. Now do the chain rule. The derivative of the inside, well, the derivative of the e function is the e function. And now the derivative of x squared is 2x. Okay, so that was review. So in general, if you have y equals sine of some function u, and you don't really know what u is, maybe it's x squared, maybe it's e to the x squared. So the derivative is going to be cosine of u, and then whatever u is, take its derivative and multiply. So if y equals a function of a, I prefer to use the letter a right there instead of the letter u. And a is a function of x, then the derivative, now I could write the derivative as just y prime, or I could be more specific and say the derivative of y with respect to x. That's a little bit better because when I put y prime, I don't know if you mean just take the derivative of f and leave the a in there, or are we supposed to have an x at the end? This is more specific because this is saying that the independent variable is x. So that would be take the derivative of f, leave a alone, and then take the derivative of a. So that would be the derivative of this. Well, there's even another way to write that. This is the derivative of f with respect to a. And this is the derivative of a with respect to x. So this is just another way to write the same thing. It's saying the same thing as this, it's saying the same thing as this, but in slightly different notation. And notice if you cancel these, dA and dA, it will leave, what's the derivative of f with respect to x? Okay, that is Math 3a. Now, what about Math 3c? What if you have more functions and more variables? So suppose that z is a function of x and y, and x happens to be a function of t, y is a different function of t. So then the derivative of z with respect to t, so this is now a function of two variables, so that means that it has two first derivatives. There's the derivative with respect to x, there's also the derivative with respect to y. So we're going to need to do both of those. So there would be the derivative of z with respect to x. But this part is saying that your answer is supposed to be in terms of t. So we also need to take the derivative of this with respect to t. That's half of it. And now go back to this function and take the derivative with respect to y. So that would be the derivative of z with respect to y. And now I need to take the derivative of this function. So take the derivative of y with respect to t. Okay, now there's a slightly different way to look at it, and that's called a tree diagram. And it goes like this. Here's the original function z. And we need to take the derivative of it, and there's two derivatives. There's the derivative with respect to x. There's the derivative with respect to y. And then we would need to take the derivative of x with respect to t. Over here, take the derivative of y with respect to t. And so you follow this down, and this gets multiplied. So the derivative of z with respect to t is equal to, so you just follow this down and multiply these. The derivative of x, the derivative with respect to x, and then the derivative of x with respect to t, plus, so there's a big plus in here, the derivative of z with respect to y, and then the derivative of y with respect to t. So this is the same thing as this, but it's just a different way to organize the information. And when you have more and more variables, then this tree diagram can be even more helpful. So now, how about some examples? So for example, let's say that z is equal to x squared plus e to the x times y. And x is equal to sine of t, y is equal to cosine of t. So with the chain rule, there's basically two main ways to do it. One is like this, how we did it in Math 3A. So this, the function has already been substituted into the sign, and then I could do the chain rule like this. Or I could do it like this and say, I'm just going to leave u there to make it look simpler, and I'll put its derivative right here. And then you do it in pieces, or you could do it all at once. And so we're going to do that in two ways and get the same answer. So first way is substitute, and then find the derivative of z with respect to t. So just directly substitute in that this is going to become sine squared of t, and this is going to be e raised to a sine times a cosine. So the direct substitution way looks like sine squared of t plus e raised to both x and y, sine times cosine of t. So there's the function. Now you can directly take the derivative with respect to t. So the derivative of z with respect to t, the derivative over here, I need to use the power rule, the 2, bring it down in front and multiply, subtract 1 from that exponent. Then take the derivative of the inside function. The derivative of sine is cosine. Now move over to the e function. The derivative of the e function is the e function. And then take the derivative of this exponent. And for that, I need the product rule. So the derivative of sine is cosine. And then this cosine will still be there. That means there's cosine squared. Plus, leave this one alone and take the derivative of cosine, which is negative sine. When it's multiplied with this, that means it's going to be negative sine squared. So that is the direct way to do it. You directly substitute the functions in and then take the derivative. Now part B, use the chain rule. So that would be the derivative of z with respect to t equals you take the derivative of z with respect to x, and then the derivative of x with respect to t. That's half of it. The next half is take the derivative with respect to y and multiply that with the derivative of y with respect to t. Okay, so we basically are doing it in pieces. This piece right here, take the derivative with respect to x. So the derivative with respect to x is equal to a 2x plus the derivative of the e function is the e function. And then in here, the y is being held constant, and the derivative of x is 1. So that means we have to multiply by 1 times y. I'm going to do this part. So I do these parts first, and then I do these parts second. So the derivative with respect to y. Well, since this is being held constant, the derivative is 0. The derivative of the e function will be the e function. And then when you go to take the derivative of the exponent, the x is a constant. The derivative of y will be 1. So that means it's 1 times x. Okay, now for this part, the derivative of the x function. Well, the x function is sine, so the derivative of that is cosine of t. And the derivative of the y function. So the derivative of this will be negative sine of t. Now let's put the pieces together, and we should get the same answer. So the derivative with respect to t of the z function, so you then take this one, so that will be 2x plus, and I'm just going to move the y in front. Now that needs to be multiplied with the derivative with respect to t for the x function. So that needs to be multiplied with cosine of t. Plus, we need the derivative with respect to y, so that's this function. I'm just going to move that x in front. And then that gets multiplied with the derivative of y with respect to t. Now, the only problem is this is saying that t is supposed to be the variable. So that means I need to replace all these x's and y's with x is equal to sine, y is equal to cosine. So this would be 2 times x, and x is sine of t, plus y is cosine of t, e to the sine of t cosine of t, and then all of that gets multiplied with cosine of t. Then plus this part, so x gets replaced with sine of t, and then there would be e to the sine of t cosine of t, and then that gets multiplied with negative sine of t. So did we get the same thing? So here, circled, are the two answers. Are they the same? So this one says you should have a 2 sine times cosine. 2 sine times cosine. This one says you should have the e function and then multiplied with cosine squared minus sine squared. Well, here's the e function, and when you multiply those two, that's the cosine squared. And if you factor the e function out of these two, this would leave minus sine squared. So they are actually the same. Okay, now, next example. What if w is equal to v times sine of u minus u times v squared? And u is equal to x plus e to the y, and v is equal to x squared. Let's find the derivative of w with respect to x. Or in other words, the derivative of w with respect to x. So this would be, right now w is a function of u and v. So take the derivative of w with respect to u, and then take the derivative of u with respect to x. Next up, plus take the derivative of w with respect to v, and then take the derivative of v with respect to x. All right, now what do those parts look like? So the derivative of w with respect to u. So this is a constant. The derivative of sine is cosine. So this will be v times cosine of u. Taking the derivative with respect to u means this becomes a 1, and this is constant. So minus 1 times v squared. Now I'm going to still be working with w, but take the derivative with respect to v. So the derivative right here will be a 1, so it leaves 1 times sine of u. Taking the derivative right here is a 2v, so we'll have minus 2 times u times v. Now on to this part, the derivative with respect to x. So the derivative right here will be a 1. This is a constant, so the derivative is 0. So the derivative with respect to x is just going to be the number 1. And we need the derivative of v with respect to x. So the derivative of this will be 2x. Now put all the pieces together. So the derivative of w with respect to x will be multiply this one with the derivative with respect to x. So multiply this one with this. And then times 1. Plus, take the derivative with respect to v, so that's this one, and then multiply it with this one. So we'll have sine of u minus 2u times v, and then that gets multiplied with the derivative with respect to x right here with 2x. Then the last thing is, this is saying that the variable is supposed to be x. So replace the v with x squared. Replace the u with x plus e to the y. And then v squared means you need to square both sides on this one, so that's going to be x to the 4th. And then plus sine, and replace the u with x plus e to the y, and then minus 2 times the u and the v, and then that whole thing is still multiplied with 2x. So that is my final answer for that one. Okay, now just one more. And that is, what about the old-fashioned just dy dx, like we used to use in Math 3A all the time? So look at this example. This is going to be an implicit function. So the function is x times y plus x e to the y equals 0. So with this function, we cannot explicitly solve for y. We just need to take the derivative. There's going to be some y primes in there, and then solve for y prime. So take the derivative right here. So right now I'm just doing this as a Math 3A problem. but you'll see the point in a second because it does become a Math 3C problem very shortly. So take the derivative here. That requires the product rule, and we're taking the derivative with respect to x. So the derivative of x would be 1, and then the y stays there. Then plus, leave x alone and take the derivative of y. And you could call that dy dx, or you could call it y prime for short. Plus, take the derivative right here, so that's 1, and then leave e to the y alone. Plus, leave x alone, and the derivative of e to the y is e to the y. And then the chain rule will say also take the derivative of y. So we have an extra y prime. Okay, now this term and this term, they both have y prime. So I'm going to leave those two there, and these two terms that do not have y prime, I'm going to move them to the right side. So subtract y and also subtract e to the y. And for these two, I can go ahead and factor out y prime. So that would leave x plus x times e to the y. And then divide. So y prime equals, with this, I'm going to factor out the negative because I'm trying to make a point. And now divide both sides by this. There we go. There's y prime. Now that was Math 3A. Now let's do this with Math 3C. So once it's set equal to 0, then just call all of this your function, which I'm going to call capital F. So capital F equals this. Now let's do this with Math 3C. Take the derivative of f with respect to x. So y is going to be a constant. The derivative right here is 1. So that's going to leave just y. Plus, the same thing is going to happen right here. The derivative of this is 1, and this is a constant. So there's that derivative. Now take the derivative with respect to y. So that means the derivative right here would be 1, and this would be a constant, so it's going to be x times 1, that's just x. And taking the derivative with respect to y means the x just sits there because it's a constant, and the derivative of e to the y is e to the y. And then look at what just happened. This is right there. And this is right there. So it turns out that you can do the problem like this in Math 3A, or you can do it faster by using this idea. Use Math 3C. You just divide negative f with respect to x, f with respect to y, and that's how you get dy dx in two different ways.